Well, hello everyone. This is once again KP the Math G. I am about to do, I want to say, my 86th video. All of them calculus based. I'm proud of that. I love this. And what we've been doing in the last few videos is that we've been taking questions from different, I look up questions and I pick certain ones out that I think you're going to need. You need them all, but I pick out certain ones and then go with that. Now, what this is, what you're looking at here are two pictures. This picture here is a graph of velocity in relation to time. Okay? Now, this green line represents runner A, we call runner A, two runners A and B. This is runner A's velocity. Okay, the green line represents that. Keep that in mind. The runner B, let's see, here's the problem, and I'll just go ahead and read it to you. Two runners, A and B, run on a straight track for t between 0 and 10, including 0 and 10 seconds. Okay? The velocity of runner B is given by, well, the velocity of runner A is here, just like I showed. Runner A is going to be in the form of a graph. Runner B is in the form of an equation, 24t over 2t plus 3. So what we've got to do is part A. There's three parts to this. We're going to try to get to all three. We might not, but I'm going to at least try to get A and B for sure. Find the velocity of runner A and runner B at time t equals 2 seconds. By the way, before I forget, this was during the year of 2000. Free response, question number 2. And if you want to Google that and look that up, you're welcome to do that. You might can even get you a printout copy of that and read it along with me. Okay? I have to abbreviate things most of the time because I just don't have enough boardroom. But now I'm not complaining about it because I've got more board than I ever thought I could ever have, and that's thankful to my good wife who loves me and got me this board for me. Okay, so I appreciate her for doing that. Okay. Well, anyway, runner A velocity is the graph. Runner B velocity is given here. The first says find the velocity. Well, the velocity is already given you. People sometimes ask, KP the Math G or whoever, when do we know to take a derivative? When do we know to take an antiderivative? Well, folks, this is a graph of velocity. It tells you here velocity in meters per second. This is a graph of velocity. Now, do we need to take the derivative of this? What happens if you take the derivative of v? V prime at t. You're right, you get acceleration. What happens if you take the antiderivative of v at t? That's right, you get a distance. Okay? You get a certain amount of distance. How far did the person go? Okay? So, we already have velocity. Think about it. If you already have velocity, you don't need to take a derivative or an antiderivative. And I know I grappled with that myself. Sometimes it's already staring us in the face. So we have to take it for what it is. This is velocity. This is a velocity equation. Now what's the velocity equation for this? Well, I know this slope is, oh by the way, this is 3 comma 10, and this is 0, 0. So I know that the graph of this velocity, you want to say v at t, whatever, okay, is equal to, we want to try this out and we're going to look at this. It says at t equals 2 seconds. Okay, well anyway, v at t is, in this particular case, we're only looking at 2, and 2 comes up to this slanted line here. Well, I want to find out what the equation of that slanted line is. You see what I mean? Now, I know that the slope is 10 over 3, and since this y-intercept, or actually v-intercept, is at 0, 0, I can just say, well, that's t. Well, now I just want to find v at 2 times 2. And see, the answer, if you look at the answer, it's not going to explain this to you right here. You just got to know that. I had to think about it just for a little bit. I said, well, I need a velocity equation for this piece of line here, because I'm only going over 2 spaces. Anywhere beyond 3, I need this equation here, don't I? Which, by the way, is v is equal to 10. It's constant, isn't it? Okay, now, what am I saying here? Okay, at 2. Plug that in. Well, I'm already here to figure this out. 20 over 3. Use the proper units. Well, meters per second. Meters per second. That's it for this one. Runner A, 20 over 3. I guess that's probably 3 times 6 is 18, 19, 20. So 6 and 2/3. If you want to be a little bit precise about that. Meters per second, and some people say 6.667 if you want to do that. 2/3 is, you know, just that, 0.66666, you know, like repeating decimal. Okay, so anyway, 6 and 2/3 meters per second, 20 over 3 meters per second. I think probably you could get away with just saying 20 over 3 meters per second. Good enough. They can't count it incorrect if you've got this answer right here. Cannot. It's there. You got it. You figured it out. Okay, but you got to know this right here. Alright? Now, this one's already given right here. Okay? I just need to plug in the 2. Alright, so maybe I can squeeze that in right here. So v at 2, I hope you can read this, is equal to 24 times 2 over 2 times 2 plus 3, and that is 48. Now let's see, let's write that a little better and a little bigger. 48 over 4 times 3, 2 times 2 is 4, 4 plus 3 is 7. And that 2 is, let's see, I will say that is 6 point something. Okay, 6 times 7 is 42, 7 times 7 is 49, so 6 and 6/7, alright, meters per second. So 6 and 6/7, I don't know. Alright, and I think they do put it in decimal form, but it's okay. Either way, you got this, meters per second on this one as well, and that's it. You don't need to do any more than that. Let me see what they have. Alright, I do have their answers, and I'm not cheating. Alright, 48 over 7 is correct here. That's one way you can say it. And you could say that's equal to 6.857 meters per second. This is 6.667 or 666. Either way you want to do that, meters per second. I could leave it at 6 2/3. I could leave it at 20/3. Ever how you want to do that. But that's very close to each other. Okay. Alright, so that's what you get there on both of those. I guess they tried to find something that would get real close, these very close to each other. Alright, that's part A. Alright, so that's how you do that. Part B, alright, I'm going to erase, I may have to turn this over. So let's do that. I don't know if I'm going to. Now, part B is this word right here. At time t equals 2 seconds. Well, what is the acceleration? Well, let's see. Let me make sure that is the question. All right. B part says find the acceleration of runner A and runner B. Now, the acceleration, remember, V prime at t, okay, is equal to A at t. So the slope of the velocity, alright, is equal to the acceleration, alright, is equal to the acceleration. Alright. So I want the slope of the velocity at t equals 2. Well, let's flip this back over. I think we can get this answer, and I'll flip it back over. What's the slope of this? 10/3, isn't it? As long as we stay less than 3, I could say 1. At t equals 1, the answer is still 10/3. The acceleration is 10/3 all the way up till time t equals 3. Okay? Alright, and so that's the slope. And then after which the acceleration is 0, because the slope is, if this is the slope here, then it's flat. Right? So that's what I'm talking about. This person is not accelerating because it's going at a constant velocity. Alright? So anywhere between 0, I could say, alright, 1/2. What is the acceleration at t equals 1/2? Well, it's still the same thing as t equals 2. It is 10/3. The slope, you could do this. 10, the slope is equal to 10 minus 3, 10 minus 0, 10 minus 0 over 3 minus 0, and that's just 10/3. That's what the slope is. That's equal to the acceleration. So we've already answered that side of it. Alright, guess what we got to do here though? 24t over, we got to find what this derivative is, don't we? Alright, that's a little different because this is an equation. Alright, well, this was an equation too. There's your slope. Right off the bat, you could just get that, 10/3. Now, of course, they say give the proper units, so that would be what? Meters per second per second. So meters per second squared. You got it. There's that one. Okay, runner A is done. Runner B, 24t over 2t plus 3. 24t. Alright, so B of t is 24t over 2t plus 3. Making sure. I don't want to be wrong about this. Alright, KP the Math G. It does not hurt to double check. I have not found that to be a sin yet in doing problems like this. Now, of course, I'm getting older. I know. But, doesn't matter. I like being good. I want to be correct about this. If I'm going to find the derivative of this doing the quotient rule, I want to be right about this. If you put a minus 3 right here, voila. Oh, well, alright. Or if you make this 3t plus 2, we're in trouble, right? See what I'm talking about? Alright. Okay, that's my spiel. B prime of t. Alright, is A of t, which is. Alright, now that's equal to low d high, so I'm going to bring this up. And if I bring something up, I brought this up for the ride, I'm not going to turn around and do two things to it. Keep that in mind. I brought it up, so I've already made one move. You can only, just in chess, you can only make one chess move at a time, right? I wish there were times I could make 2, or 3, or 5. That wouldn't be fair. Move it up. You've done your job with this one. Now I'll take the derivative of this. So times 24. Oh, there it is. Now remember, on the product rule, on the quotient rule, you got to use the minus sign. Alright, so low d high minus high. Now, what's the derivative of 2t plus 3? D low. Alright, so times 2. Alright, over 2t plus 3 squared. Now, I'm going to tell you something. If you are taking AP Calculus, do not try to expand this. I could do that because I'm a retired teacher and I got all the time in the world. No, I don't. My wife keeps me plenty busy, if you know what I mean. But I keep myself busy too. Now, A at 2. A at 2. What's that? So 2 times 2 plus 3 times 24 minus 24 times 2 times 2 all over 2 times 2 plus 3 squared. Don't forget the squared. Okay, what is this? We know this is 7. So 7 times 24. So 24 times 7. 7 4 is 28. 7 2 is 14. 15, 16, 168. So 24 times 7. 2 times 2, 4 times 3 is 7. So this top one here is 168. Put it up here. Maybe we got enough room here. So we got 168 minus, okay, 24 times 2 times 2, 24 times 4, isn't it? Okay, so R 48 times 2, 24 times 4. Okay, so 24 times 4, 4 4s is 16, 2 4s is 8, and 1 is 9. So minus 96 divided by, okay, this is going to be 7 again. The 7 squared. So 7 squared is 49. Okay. Now, Let's figure this out. 8 minus 6 is 2. Alright. 2 and 6 is 8. 16 minus 9 is 72 over 49. And let's see. I want to say that that's probably what you can do. I don't think that can be. Oh, let's see. I don't think you can reduce that. So that will be in meters per. Is it meters? Meters or feet? Meters per second squared. Yes. So meters per second squared. I think what they write that down as, I do have this correct. It is 72 over 49, which is about equal to 1.469 meters per second squared. Alright, so the other one was 10 over the A one. I had to go back over 10 over 3. 3 times 3 is 9. So about equal to 3 1/3 meters per second squared. Isn't that right? 3 times 3 is 9 plus 1 is 10. Yeah. And if you put it as decimal form, 1/3 is 0.333. So 3.333 if you want to do that. Alright. 1 is accelerating. Let's see, it looks like runner A is accelerating at a faster rate than runner B, which is only 1.469 meters per second squared. Alright. That takes care of A and B. And I think what I'm going to do is reserve the part C then for another video, although I'm so tempted right now to go ahead and do that, but I'm going to reserve that. Okay, so we could easily figure out it asks for total distance of runner A. That would be easy to do, okay? And runner B, we would have to, now, distance. Okay, total distance, antiderivative or derivative? Yeah, total distance. Take the antiderivative, or in this case, a definite integral from 0 to 10. You would have to do that. Let's do that on another video, okay? I think sometimes I run these videos a little bit long, and you might get a little bored with looking at too much information at one time. So what did we do? We just did one equation, or we compared the velocities of both. You didn't have to do anything because it was already there, see? So no taking the derivative there at t equals 2. And then on the other side we took care of what it would be, what the acceleration is over t equals 2. Okay, at time t equals 2 seconds. Okay, 10 over 3 for runner A, or 3.333 meters per second squared. And then on the other side, we had to do this problem here. We had to take the derivative of v, which is 24t over 2t plus 3. Once you find this derivative, I would not try to group all this stuff together. First of all, you don't have a lot of time on these tests. I hate to say that, but time is, I mean, you may have, but still, you don't want to waste a lot of time. Okay, that's what I'm trying to say to you. And so just plug it on in. That's what they do on these tests too. That when they find that, they just go ahead and plug it on in, and then find the answer to this. This is 72 over 49, 1.469 meters per second squared for runner B's acceleration. Make sure you put your unit. Make sure your units are correct. Meters per second for velocity, meters per second squared for acceleration, and for distance, total distance, which we're going to find in the next video, is meters, right? And it's going to be a pretty easy problem to do, but I just want to reserve that for another time. Got enough to digest, don't we? And it's good. Okay, this is KP the Math G. Please, if you will, if you have not subscribed already, please subscribe. Those of you in AP Calculus taking the AB test, keep in mind that you have a mock test coming up. I want to say, I think they still do mock tests in March. I want to say they do that. It may be April, March or April, 1 2. I want to say it's March though. And then you're taking that test in May. So that gives teachers or instructors or professors a chance to go over the material with you. If you're just in a regular calculus class, this is not going to harm you at all learning this, I promise you. And you'll get a lot of it whether you're taking AP Calculus or if you're in a regular calculus class. So anyway, I hope you have found this to be very helpful to you, okay? And that you can use this and think about, I want to try to fix it where you, especially those of you who are taking that AP exam, that you don't have to think a whole lot. You can automatically just set it up. Okay, I remember what KP's Math G said about this. Just set it up and go. Okay, where you don't have to think a whole lot about it. Okay, so I do know that you're under a time limit, and that's okay. But you just have to realize to utilize your time as best and as convenient, appropriate as you can. Okay, well anyway, please subscribe if you have not subscribed already. And please make a comment if you'd like to. If you know a better way, please tell me about it. But again, as I always say, your way needs to be correct. And if it is, I will put your problem up here and show you an easier way. And then also hit that like button. I like those like ones. If you hit unlike, tell me why, please. Tell me why you didn't like the video. I would appreciate that if you would do that. I have not had anyone to unlike anything so that I've done so far. That's not saying there's a first time for everything, but I'm just saying I have not had that as of yet, and I still get viewers. I just hoping that subscribers will start coming in again pretty soon. Anyway, this is for you. I don't get any personal benefit out of it. I do love to do it though, I have to say that. Without any more ado, this is KP the Math G signing off. And as I always do, I give a signature clap. Have a great day. Signature clap. There it is. Thank you.